Hello there, everybody. Here is your warm up today. Whoop, wop, whoopity bop. There we go. Simplify that expression. Do you remember how? You're going to want to pause the video because we're ready to do it. Let's make it happen. Give that a try. Pause the video, and here we go. Can I get you guys back up here in 5, 4, 3, 2, 1? Perfect. I know that this wasn't necessarily in quarter one when we covered this thing, but we go by quarters for the review, how we taught it in 8th grade and actually how we taught it in the past. So if it seems a little bit out of order, it's because it is, and that's okay. I actually kind of like that. So let's see if we can get a little bit of help with this bad dude right here. Let's see here. Can I get a little help? Sophia, do you remember how to handle something like this? Okay, I'm really glad we're talking. So the thing of it is that I would think of this as two separate problems. You got the thing in purple and you got the thing in blue. Because really what we're doing, Sophia, is we are simplifying this expression. How can I simplify 18/27ths? Yeah, because it's a fraction bar means divide. So I'm going to grab my calculator. Me. Are you guys ready? You guys remember the song? You guys can do it with a big smile? Oh, you better be. Okay, come on, here we go. It's coming up, maybe. I heard someone say no. There you go. TI SmartView TM emulator software for the TI-30X/TI-34 multi-view. Bigger smiles. TM calculators, Texas Instruments, validating software license. ... Yay! You did it. Okay. So if you do 18 divided by 27, icky yucky. It's a repeating decimal. But even though that would be fine, you put 0.6 repeating. If you guys remember this this unit, I want that as a decimal or as a fraction? A fraction was preferred, and so we'll call it 2/3. Okay. So we're going to call it 2/3. And then, do you remember what happens to the exponents on this, Sophia? It is something else, and let me tell you why. Sophia, when's your birthday? May 3rd. Oh, I don't want to do that one. Well, you know what? Maybe I do want to do that one. If I do x to the 5th for May over x to the 31st, if I had like x times x times x times x over x times x times x times x times x times a bunch of other x's, right? We could start dividing out the numerator and the denominator like this, right? Yeah. And how many x's would be left over on the bottom if I crossed out 5 of them? 26. So I would get 1 over x to the 26th. So what did I do with 31 and 5 to get 26? What's a faster way to do that? That's right. So we take the top number and we subtract the bottom number. So this becomes 3 minus 1 is 2. 7 minus negative 3 is 10. And then 3 minus 8 is negative 5. Now that's great. Like that was enough for a level 3, but to get your 4 on that skill check, if you guys remember, we had to put everything with a positive exponent in the numerator and everything with a negative exponent in the denominator. Yeah, so does this x belong upstairs or downstairs? Upstairs. How about the y? Upstairs. How about the z? That's right. I wrote 20 instead of 10. There you go. And then that would be z to the positive 5th. Does that kind of does that ring a bell there, Sophia? Kind of remembering that? That's okay. How was your spring break? What was your favorite part? We went to New York. New York? That's awesome. What'd you do in New York? We saw a few Broadway plays. Mm-hmm. Oh, that's way cool. Were any of the Broadway plays stinkers? No. Darn it. I was going to say, if I went to New York, I would love to go see 2 Broadway shows. I'd love to watch one that was really good, and I would really want to watch one that was really bad. You know what I mean? Like, just because we don't get many plays in Salt Lake, and so the ones that we get are always phenomenal because they are like, well, it's like our one play that we really get. But in New York, there's just so many that some of them are bound to be bad, and that's funny to me. All right, guys, it is the 144th number. Did you know that 144 to the 5th power is the sum of 4 other 5th powers, which proves that Euler's sum of powers conjecture was false? That is to say, Euler believed, and Euler is like one of the greatest mathematicians who ever lived, that if you have some number, like some number to the kth power, right? That means, let's see here. Hold on. No. If you have n numbers that add up to a different number to the kth power, like n sub 1 to the kth power plus n sub 2 to the kth power plus blah 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 plus n sub 3 to n sub, like, I don't know, 7 to the kth power, and then that was equal to something else to the kth power, it would say that this number, the 7, had to be less than the exponent, and then that proved it wrong. It's Childhood Alopecia Awareness Day. Is somebody already aware of what alopecia is? Does someone know what that is? Oh, quite a few of us. Arden, what is it?
Isn't it when, like, you can't grow hair?
Yeah, when you can't grow hair in certain spots or everywhere, that's also a possibility. And it's actually way more common than you might think it is. So some people have that, and yeah, just something to be aware of. Let's see here. What's our first essential question? And I'd love to get that from Elizabeth. Yeah, what sort of material did we cover this year? What sort of material did we cover this year? Gesundheit. This is part 1, and Gesundheit again. Our Jeopardy this week is fast animals. The fastest land animal is, of course, this big cat, capable of reaching nearly 60 miles per hour at its top speed. That is, of course, a cheetah. And then spring flowers, that's a rose. I feel like I did that rose pretty good. That rose pretty good. You just pop, Hoibing shaking her head. I was like, I think I did that rose pretty good. And I just see Hoibing shaking her head. Like, my feelings, Hoibing, I feel like I did okay. Wait, where do the rest of you guys feel? Big thumbs up. Put that under a glass and it belongs in Beauty and the Beast. Big thumbs down. That doesn't look anything even like a flower. And then down it somewhere in between. Where is everybody? You wound me. All right. Anyway, moving on. Underneath all this, got a pencil.
Absolutely.
All right. It's the quarter 1, in quotation marks, because it's quarter 1 for 8th grade in the past. Rise review. We're going to start with something that's not quite a review. It's something that we just never had time to talk about, so we're going to make it really fast. One of the things you need to be able to do in 8th grade math is you need to be able to write fractions as decimals and decimals as fractions. Okay? So, for example, when I say teach, I want you to say, okay, what is 17/25 as a decimal? Give it a try and teach. Okay, can I get you back up here in 5, 4, 3, 2, 1? Hoibing, what is that as a decimal? 0.63? 68. How many of us got 0.68 for that? Hoibing, how did you get that? Yeah, it's just 17 divided by 25. Not bad at all. How about this one? What is 2.395 as a reduced fraction? I'll take improper or mixed number. See what you guys can do with that. Can you remember how to turn that decimal into a fraction? Teach! Yeah, Stephen's right. Absolutely. There's something to that. Okay. All right. Can I get you guys back up here in 5, 4, 3, 2, 1? So Stephen's getting to it, guys. Do you remember, how did your angry elementary teachers demand that you say this number? By raising a hand. Do you guys remember this? Sam, how do they make you say that? Boy, I hope they didn't make you say all that. I think there's a slightly simpler way to say it, because that would work. But what you're proposing that I write is 2 plus 3/10 plus 9/100 plus 5/1000, and icky yucky. I don't want to do that. Do you remember what it is, Ellie? Yeah, there we go. It's 2 and 395 thousandths. That's how I remember having to say it. And is that reduced though? No, so we can use our calculators to reduce it. 395 thousandths. 79 200ths. So it's 2 and 79 200ths. Also, for the record, your calculator will do that one for you. If you just say 2.395, boop, 479 200ths, and you can just take it from there. But here's the problem, and this is where something happens that's kind of weird. What is this as a fraction? 1.8 repeating. 1.8 repeating. Talk to each other about how you might be able to manage that. Teach! Try it. Yeah, see if it works. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1? I heard some of us got there. Sadie, what did you get for that?
1 and 8/9.
Yep, 1 and 8/9 is correct. Very good. And the thing is that there's a way to prove that, and I'll show you how it works. Put your pencils down. I'm not going to make you write this. But I want you to look at it. 1.8 repeating is equal to x. And x is going to be the fractional version of what I want, okay? Now, what you do here is if you multiply both sides by 10, then I get 18.8 repeating equals 10x. Is that okay, guys? You might be wondering why the heck I'm doing this, but I'll show you why. It's because I want to take away an x from both sides. What's 10x minus x? 9x. Oh, no, not 10, 9x, right? But didn't I just say that x is 1.8 repeating? If I had 18 point an infinite number of 8s like this, minus 1 point an infinite number of 8s like this, what would happen to all those 8s? Yeah, they'd be gone, leaving behind 17. Divide both sides by 9, and I get, x equals 17/9, which is 1 and 8/9. It turns out that repeating decimals follow this rule. That's like, I call it the rule of nines, where if you have something like this, got a pencil? Negative 0.54 repeating. What you really can do is turn it into a fraction. The numerator is whatever is repeating. What's repeating here, guys? 5, 4. And how many digits is that? 2. So I'm going to put it over 2 9s. And that works every time. It's the rule of nines. Yeah, and the reason it works is in order to get my decimals to line up, I would have to multiply by 100, take 1 away from both sides, which would turn it into a 99x equals 53 or whatever it winds up being. But of course that reduces, and we can just use our calculator to do that. Negative 54 99ths, which is negative 6/11. That would be it as a reduced fraction, okay? You guys okay with that? Cool, excellent. There's one type where you will have to do that funky algebra trick, and that's if it doesn't repeat right away. Like if it's 3.875 and it's the 7.5 that are repeating, that gets a little bit weird. So what we would have to do here is we would have to multiply by enough factors of 10 to get the decimals to line up. So, for example, if I did, and this time I do want you to write this down, that would give me 38.75 repeating equals 10x. But can I use the rule of nines now, guys? Yeah, since it's repeating immediately, I can call that 38 and 75 99ths, which I don't believe reduces, equals 10x. Divide both sides by 10. And this is the part where I get my calculator. 38 and 75 99ths. 38. Does it really? Well, we'll get it figured out. Divided by 10 is 1,279 3/30ths. Nice. 1,279 3/30ths. Very good. Can I tell you that one of the biggest arguments my wife and I ever got into was on a road trip to Moab because of this number? What is that? It's not zero. 0.9 repeating? Well, if you do the trick, equals x, multiply both sides by 10, that's 9.9 repeating. Are you guys okay with that? Equals 10x. Have I broken any mathematical rules? No? Everything's fine? Then I'm going to subtract an x, which over here would be a 0.9 repeating. So what happens to all those 9s? Gone, which means 9 equals 9x. Divide both sides by 9. And what's 9 divided by 9? You guys, I don't know how to tell you this. 0.9 repeating equals 1. It's not approximately 1. It's not approximately 1. It is 1. It is 1. If that bothers you, and this is the part that my wife really didn't like, because it's like I have all these ways of solving it, and she's like, yeah, but this is like a weird artifact of math. Like it proves that maybe solving equations isn't always right. Here we go. If 0.9 repeating is not the same number as 1, then go ahead and tell me a number between them. If two numbers are not the same, is there a number between them? Gotta be. So go ahead. What would it be? There isn't one, which means 0.9 repeating is 1. I'm sorry. Okay, let's see here, guys. 0.9 repeating. It's 1. Literally 1. All right, let's see here, guys. I need to grab my paper here so I can remember what there is. Another thing that we talked about in early quarters, guys, was solving double-sided equations like this. Got a pencil? 3d minus 7 equals 6, open parentheses, 1 minus d, close parentheses, plus 9d. When I say teach, I want you to say, okay, will you talk to your partners? How do I write that? How would I be able to solve that equation for d? And what do I do if something weird happens? Give it a try and teach. That's me, Shriyan. Okay.
0.9 repeated 1.
So you're saying after an infinite number of nines, you put a 1. Okay, go ahead and write that for me. If you can write that out for me. And just let me know when you're finished with the infinite number of nines, and then you can put a 1 on there. Then I'll buy it. Hi. Love that shirt, by the way.
So does that mean it works for like any number? So like 0.9 repeating equals 3?
That's correct. Mm-hmm. Because if you think about it, technically that would be 2 and 9/9, right? Which would be 2 and 1, which would be 3. I know it is weird, but it's true. It's 100% true. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1? Truman, how would you solve this equation?
So first I subtract D from both sides.
Sure.
Get
Again, that wouldn't be my first move, but it is a completely legal move that you can absolutely make. Plus 6D, gotcha.
I subtract the add 7 just to
Okay.
get back to 0. Then
So 0 equals 6, open parentheses, 1 minus D, plus 6D, plus 7. Again, this isn't the way I would go about it, but so far, everything's good. We haven't broken any rules. It's all good in the hood. Keep going. 7's over here on the right side now. There was nothing for it to combine with because everything's stuck in the parentheses over there. Are you thinking there might be a simpler way to do this? I'll tell you what, let's put a pin in that, Truman. That's okay, that's okay. Again, this would work, but I definitely don't think that's the easiest way to do it. Personally, Truman, I like to simplify first. That's my personal preference. So if we do 6 times 1, what is that going to give me, Truman?
6.
And then 6 times a negative D?
60.
Yep, so negative 6D. And then that's plus 9D. And on this side, it just says 3D minus 7. Nothing happening here. Now we can start simplifying a little bit. What's negative 6D plus 9D?
3D.
Yeah, 3D minus 7 equals 6 minus 3, or sorry, plus 3D. Now we can, now we can take 3D from both sides, which asserts that negative 7 equals 6. That's right. So since that is untrue, you would say there is no solution. How many of us got no solution or see how we got that or aren't too alarmed? Awesome. Very good. Do you guys remember scientific notation a little bit? Like, for example, if I have negative 94 million dollars, that's bad. But to write that in scientific notation, do you guys remember? Does the decimal go here on the brown, here on the pink, or here on the blue? Where does the decimal belong, everyone? It belongs on the pink. So it would be negative 9.4. And then you would have 1, 2, 3, 4, 5, 6, 7 times 10 to the positive 7. You guys remember that okay? Awesome. The last thing that we needed to make sure we talked about was, do you guys remember how to tell if a number is rational or irrational? So a rational number is a number that can be written as a fraction of integers. So even if it looks horrible, like 4/17, I'll tell you right now, 4/17 does not look like it repeats. But is it a fraction of integers? Yes or no? Yeah, since you can count to the numerator and count to the denominator by 1, you're in good shape. So that's rational. Irrational numbers come in 3 flavors in 8th grade. There's imperfect roots, like the square root of 12. That's irrational. There is multiples of pi, so like 4 pi over 9. That would be irrational. There's weird number patterns like 4.12, 112, 1112, 11112, and so on. Everything else is going to be rational for you guys. And then if it has a repeating decimal, it's definitely rational as well. Perfect. Here's what I want you guys to do. We've got about 15 minutes because we do have warrior time today, but I believe you're supposed to stay with your second period. I'll double check to make sure that that's true just for today, I think, but I'll double check it. When I say teach, I want you guys to say okay. I want you to open up your Chromebooks and you can work on 17.1. That is your Rise Review Quarter 1. Big quotation marks around Quarter 1. Keep it going, guys, and teach. Guys, you can do so much better than that. Teach.